Hi guys, it's Miss Adams, and we're going to be looking at the Unit 6 material from the Algebra 1 Midterm Review for the 2022-2023 school year. This material covers applications with exponential functions. So let's go ahead and jump into it. This first question says there are 45,000 bacteria that are increasing at a rate of 11% each day. It says write an exponential function that relates to this situation. Well, I've got an initial value, so my a sub 1 is 45,000. I've also been given a rate of 11%, but I need to convert that 11% into a decimal, so that's going to give me 0.11. And if I'm writing an exponential function for this, this is going to be an exponential growth because it says it's increasing. So my function is going to be that y is equal to my initial value of 45,000 multiplied by 1 plus 0.11. raised to the x power. I could also write this by combining those terms inside the parentheses as y equals 45,000 times 1.11 to the x power. Then it says find the number of bacteria after 3 days. I'm going to replace my x value with 3. So y equals 45,000 multiplied by 1.11 to the third power. So use your calculator. You got 45,000 multiplied by 1.11, raise it to the power of 3. And guys, we're dealing with bacteria here, so let's just go ahead and round to the nearest whole number. So this is going to be approximately 61,543 bacteria because my decimal values are 0.395. So I'm just going to leave it at 61,543. Problem number 2 says that Mr. Sakita bought a new car for $19,000. If the car depreciates at an annual rate of 18%, what's it going to be worth after 6 years? So I know my initial value is $19,000, and then its rate is 18%. If I write that as a decimal, that's going to be 0.18. And we're depreciating, which means we're going to be losing value, so this is going to be a decay function. So I've got y is equal to my initial value of 19,000 multiplied by 1 minus 0.18 to the x power. Or I could write this by combining those terms, the 1 minus 0.18. That could be written as y equals 19,000 multiplied by 0.82 to the x power. Then it asked me to find the value after 6 years. So I'm going to replace x with 6. So y equals 19,000 multiplied by 0.82 to the 6th power. So that's 19,000 times 0.82 raised to the 6th power. We're dealing with money here, so we're going to have 2 decimal places. So that's going to be approximately $5,776. My decimals it gives me is 0.126757. So I'm going to round that to 0.13. So that's $5,776.13. Now, number 3 is just asking us, what does this mean in context? So it says, Ryan just bought a new car for $38,000. His car loses value each year at a rate of 19%. The decay function for this scenario is v of t equals 38,000 times 0.81 to the t power. Explain what v of 4 equals 16,357.75 means in terms of context. That just means after 4 years, the car is worth $16,357.75. So it lost value in those 4 years. Number 4 is very similar to a problem that you had on your test. So it says the population of Georgia starting in the year of 1990 raises at a rate that's not given to you. You're going to use the following equation to answer the questions below. So it says f of x equals 8,186,453 multiplied by 1.0235 to the x power. My change factor in this case is going to be what's inside my parentheses. That's 1.0235. This is bigger than 1, so it is a growth factor. To find my rate, I'm going to take that 1.0235 and subtract the value of 1, which is going to give me 0.0235. But because I had a growth factor, this is also going to be a growth rate. And I now want to convert that to a percent. So I'm going to multiply that by 100 to get me 2.35%. So that means the Georgia population is increasing at a rate of 2.35%. This next question should be something that you know off the top of your head. We're looking at our different values of n. Compounded monthly means it's going to happen 12 times a year. Quarterly is 4 times a year. Semi-annually is 2 times a year. Compounded annually is 1 time a year. Weekly is 52. And daily is 365 times a year. Problem number 6. So it says if you deposit $14,000 into an account paying 6.7% annual interest compounded monthly, how much money will be in your account after 25 years? So this means I need to use my compound interest formula, which is A is equal to P times 1 plus my rate over my N, which is my interval, times, or to the power of N to the T power, or N times T. In this case, my principal is at $14,000. And I'm multiplying it by 1 plus, my rate was 6.7%. So if I do 6.7 divided by 100, that's going to give me a rate of 0.067. Then it said it was compounded monthly. So compounded monthly is going to give me an N value of 12. And I'm going to raise this to the power of 12. And then I'm also looking at a value after 25 years. So I'm going to do 12 times 25. And we're going to plug this into the calculator the same exact way. So I've got 14,000 multiplied by 1 plus the fraction of 0.067 divided by 12. I'm going to raise that to the power of 12 times 25. That means after 25 years, your account will have a balance of $74,395. And my decimals here are 0.735, so I'm going to round this to 0.74 or to 74 cents. Number 7 says I've got an initial value of $185,000 at 7.9% compounded quarterly for 13 years. So I know that my amount after 13 years is going to be equal to my initial value of $185,000 multiplied by 1 plus my rate of 0.79, or excuse me, so I had 7.9%, divide that by 100. That gives me a rate of 0.079. This is compounded quarterly, or excuse me, quarterly. So that's going to be an N value of 4. And that's going to be raised to the power of 4. And I'm looking after 13 years, so 4 times 13. So I have $185,000. Multiply that by 1 plus the fraction with a denominator, or a numerator of 0.079 and a denominator of 4. And raised to the power of 4 times 13. So after that 13 years, your account is going to have a balance then of $511,499.08. And let's look at this last problem. This is a comparison problem. So Jonathan is going to want to invest $24,000 into a savings account. The bank offers 2 savings accounts, a basic account and a premier account. We're going to find the amount that would be in Jonathan's account after 30 years for both the basic and premier savings accounts. Then we're going to compare the 2 accounts to find which savings account would benefit Jonathan the most. The basic account pays a 3.8% annual interest compounded weekly. So I know for both of these, my initial value is $24,000. And in this case, the rate for this one is what's changing. So my rate is 0.038, and also my interval that is compounding is changing. So this says weekly, so it's going to be 52. And I'm going to raise that to the 52nd power times. I'm looking at how much is going to be in the account for both of these over 30 years. So I've got that $24,000 as the initial amount. Then 1 plus 0.038 divided by 52, raised to the 52 times 30 power. So after 30 years, in the basic account, Jonathan's going to have $75,011. with 20 cents. For the Premier account, though, we've still got that $24,000 initially, but my rate is now increasing to 0.057, and it's compounded semi-annually. So that means it's going to be compounded twice a year. And that's going to be 2 times 30 as my exponential value there. So I've got 1 plus the rate of 0.057 divided by 2. In the calculator, raised to the power of 2 times 30. For the Premier account, Jonathan, after 30 years, is going to have $129,559.42. So if I'm comparing these guys, the one that's going to be the most beneficial is the Premier account, because you gain more money by just leaving it in there for 30 years, or for a time of 30 years. All right, guys, that is everything on this Algebra 1 midterm review for the 2022-2023 school year. Good luck, guys.